Welcome to Resoundingly Human, the podcast by Informs. I'm Ashley, and in each episode, I talk with an Informs member to explore how operations research, analytics, AI, and more are transforming our world, from healthcare and transportation to public policy and sustainability. In this episode, we're continuing our special relaunch series by welcoming one of Inform's annual meeting plenary speakers, a pioneer in the fusion of machine learning and optimization, and a leader in advancing AI for real-world engineering challenges. My guest today is Dr. Pascal Van Hentenryck, the A. Russell Chandler III Chair and Professor in the H. Milton Stewart School of Industrial and Systems Engineering at Georgia Tech. He also serves as the director of both Tech AI, Georgia Tech's Artificial Intelligence Hub, and the NSF AI Institute for Advances in Optimization, or AI4Opt. Pascal is a fellow of Informs and AAAI and has made groundbreaking contributions to constraint programming and optimization systems that are still used in industry decades later. His current research focuses on integrating AI with mathematical optimization to solve incredibly complex and large-scale problems in energy, transportation, supply chain, and more. At this year's Informs annual meeting, he delivered a plenary address titled Learning to Optimize: Foundations and Industrial Impact, exploring how machine learning and optimization can work hand in hand to meet real-time demands in today's dynamic systems. I'm so thrilled to have him here with us today.
Yeah, thank you, Ashley. I'm super happy to be here and talking with you.
So Pascal, to help set the stage, can you share how your work sits at the intersection of AI and optimization and why that combination is so important today?
Well, I think it's very simple. So this integration of AI and optimization is really the mission of the NSF AI Institute that I'm leading, AI4Opt. So this is an institute in advances in optimization. And really what we believe is that if you combine AI and optimization, you can do something, you can get outcomes that the two technology cannot deliver independently. And that's really what we are trying to do. So something that, 5 years ago we couldn't do, or 5 years from now, we will be able to do something that we cannot do now. And I think that's possible by merging these two technologies.
So your plenary focused on parametric optimization, problems that are solved repeatedly across dynamic environments like supply chains and power grids. What makes these problems so challenging, and why are traditional approaches often falling short?
Optimization technology is amazing. You give it, a model, you have a model, you give it some input, give it to a solver, you get, an optimal or a near optimal solution. So when it works, it's amazing technologies. The problem is that sometimes for applications that are really important, it's too slow. So when you have these real-time constraints, or you have human operators in the loop, or you run massive simulation that have to go extremely fast, essentially the system is, the optimization model is going to take too much time to be solved. And so this is what we are really addressing. And if you think about it, most of the existing solver, when they solve these problems that are that you solve repeatedly, they throw everything away from one run to the next. And so what we are thinking about is, can you actually use all the experience that you have seen or that you will see and move most of the computation burden offline such that in real time you can solve these problems in milliseconds. That's really what we are trying to do with these parametric optimization problems. And this is rooted in real life, right? So this is exploiting the fact that we are solving problems on infrastructures, and these infrastructures are not changing very fast, right? So you don't build a transmission line every day. You don't, build a new key cranes every day. So the infrastructure is stable, you solve the same problems, and the key point is that you have a lot of information that current optimization technologies is not using. And that's where this combination of AI and optimization, I think, has huge opportunities.
So one particularly fascinating part of your talk was the idea of optimization proxies, learning the input-output relationships of complex models to get near optimal solutions in real time. Could you briefly explain how this works in practice?
Well, I think it's very simple. I think you can view everything as a function. You have some input and you produce some output. So that's the first thing. So an optimization model is, you get some input, the output is an optimal solution, right? So this is a function. Now, machine learning is a universal function approximator. So initially we thought, well, we just use machine learning and then we replace the optimization solver. This is magical. But in practice, it's a little bit more complicated. You have all these constraints, physical constraints or engineering constraints or business constraints that you have to satisfy, and they are non-negotiable. You have to satisfy them. And so essentially what you see is the machine learning model is never going to satisfy them. So what you need is another piece and what we call a repair layer or projection layer that takes essentially the approximation that you get from the machine learning model and get a feasible solution. And so I think this is this key. This is a combination of techniques from machine learning and then more reasoning techniques, more optimization techniques, or essentially that. And so and when you have something like this, you get the best of both worlds. You get the speed of machine learning, but then you get the performance guarantees and the feasibility of optimization technologies. So you get an optimal solution. You can do that with the dual models, and then you get also performance guarantee. This is kind of magical. You essentially have approximations of these optimization problems very, very quickly. Does that make sense?
Yes. Probably more so to our listeners than to me.
Yeah.
So Pascal, you also discuss methods that blend optimization with supervised learning and reinforcement learning. I'd love to hear what kinds of industrial applications are you seeing the most impact in, or even potential for future breakthroughs?
Yeah, so that's a great question as well. So I think we have been working on these combinations of supervised learning and reinforcement learning in problems that are what we call sequential decision-making problems. So you don't solve a problem once for all. It's a problem, you make a decision and then something happens, uncertainty is revealed or people are doing something, and then you have to make another decision. So you have this sequence of decisions that you have to make. And this is where we have found that these combinations of reinforcement learning and supervised learning or self-supervised learning is very, very, very useful, because the reinforcement learning is all about, kind of solving these sequential problems. But they typically ignore, the domain expertise and the optimization. And once again, when you combine these two, you have something that can be really magical. Applications are everywhere. We have application mobility in transportation, also in power system. Now that we have in storage in power system, things are very different. You have to decide, what you're going to do later on, how you can use this, these batteries for actually shaving the peaks at some point or regulating frequency. And so this is a very different world now, where you have these sequential decision-making, problems that are coming all the time. And these combinations is, I think, very unique. You're going to see a lot of progress in the next 5 years in that space, I believe.
Another area we're hearing a lot of buzz in is responsible AI and explainability. In domains like energy or logistics, where decisions have big consequences, how do you balance performance with transparency and reliability?
Yeah, again, not surprised by the question, because this is something that comes up all the time. And I think there are several points that I'd like to make here. The first one is that what we do in the AI Institute here on these problems is we try to be trustworthy by design. That basically means that we will have the same kind of guarantees as the optimization model, but no, we are using a combination of AI optimization. So we can guarantee feasibility, we can guarantee, kind of high quality solutions. So that's the first thing. We want to be trustworthy by design. It's not like we are trying to patch something. We are thinking very hardly at the beginning on making sure that we will meet the constraints of these highly, high stakes applications. That's number one. Number two, I think in many of these applications, if you see what is happening in real life, you have operators in the loop. There is always somebody looking at, is this reasonable or not? Because this, as you said, this is high stake decisions and people are still there. They're still looking, right? So, and I think this is very healthy. It's like they understand the system at a level where, they can see that something is wrong, if something is wrong. And so I think that's also good. You have to give the information to the operator. You have to visualize the solution that you have. You have to make them understand why this is coming from. Now, the third point that I want to make is that you want to try to explain these solutions to the operators, to the humans in the loop. And that's something that is very difficult. I mean, an optimization model is something that is very complicated and is not very easy to explain. But there are things that you can do. You can do counterfactuals. You can say, hey, if you do this, this would be the consequence. That's why we are doing this. You can also, do some form of analysis saying, okay, so if this constraint is violating right now, this is because of this and this and this, and you can try, to find out, what is actually, what are the root causes of this particular symptoms that you are observing. So that's the kind of things that we're working on. I don't mean by any means that we have solutions for all of this, but this is the direction that we are taking. And I think this is very interesting because people have not really addressed those issues in the past at a level where, really the operators wants to see. But I think we have an opportunity now that we have also machine learning and AI, because they allow you to do things at a speed which is very different from what we used to do. Sorry.
I appreciate that one point you made that it can be very complicated to have to explain, these really
Yeah.
technical things to people that just don't have that background. I imagine that's part of a challenge that is probably a really big part of it.
Yeah, and I think no, it's a very interesting thing, that a very interesting situation that we are in, because if you use AI, people will say, "Oh, I need an explanation because this is a black box." But optimization solver has been a black box for 70 years, and people have never really kind of raised those questions. But no, this is AI. AI is to be explainable. So I don't mean to criticize anything here, but I just mean that I think sometimes the questions can move from one community to another one, and it is very healthy. And then people start realizing that, yeah, this is a challenge. This is not a challenge only for AI, it's a challenge for us. We have not been addressing this. And by putting things together, you can do things that otherwise you couldn't do. Again, I'm repeating the mission that I see, which is super important. Like, can you merge things?
100%. So, Pascal, you've been at the forefront of optimization and AI for decades, from constraint programming at Brown to AI for Opt at Georgia Tech. Was there a specific project or breakthrough that felt like a turning point in how you approach your research?
I don't really think so. I mean, this is like a continuous process, right? So most of the time, in a sense, when I think about the great ideas that some of my groups came up with, I think what happened is that you were putting different ideas together. It's like you meet the right person at the right time, or you meet someone and someone says something, and then that something triggers something in your mind, and you say, "This is what I needed." And so I think it's always, I think the most of the interesting research topics that I think we have studied and we made some contributions have come from putting different things together and getting ideas from other people. And there is another thing that I want to mention, is that sometimes you do something in a field, and then because it's your own, you think about this and you work on this, at some point you get stuck. You kind of run into circles. And then you forget about that area, and then somebody comes up with a completely new idea. And then you say, wow, this is interesting. I can put these two things together and I can solve the problems that I was stuck with. That happens many times in what we have experienced. It's like, I think the important thing is being open to ideas coming from very different people and trying to see how they can be applied to some of the challenges that you are dealing with or you were dealing with and got stuck. So I think it's kind of a circle in a sense. You see other people making new contributions and you say, wow, this is interesting. I can use that and solve some of the problems that I had. So in a sense, it's like 5 years period. So, a career like what I have experienced is like 5 years on a project, 5 years on another project, and so on. But then you can go back to a previous project and say, hey, no, I can do this because this person has made this amazing contribution. You see what I mean?
I do. So it's not really one big aha moment, but just continuously learning and meeting new people and experiencing new ideas. And I imagine sharing your expertise and ideas with others too.
Yeah, I'm sure we do that too. We give ideas to other people. I mean, that's what is nice in science. But sometimes it's like you read something, my thesis, like, I'll tell you later on, but it's like one thing that I saw, and then another, in another case, it's like talking to someone and they say, oh, why don't you think about this? And then we work together and then something happens. You see what I mean?
Absolutely. Pascal, you are also mentoring many students and leading major research institutes. What excites you most about how today's students are approaching all these challenges differently? And what do you think that they'll do that perhaps your generation didn't?
This is a difficult question because, students are like kids, my kids, for instance, they are very different. And so you have a wide variety of students. And it's very difficult to generalize. So I'm going to give you kind of more general things that I see.
Perfect.
But again, they don't necessarily apply to everyone because there are so many different personalities. And this is one of the things which is interesting. You talk to one student and the student thinks about this and the other student thinks about something completely different. So it's tough to generalize. I think also students these days have a lot more pressure. It's more difficult to be a student, to be a scientist these days that when I was young, and I think the big difference now is that everything is more connected. Everything is more kind of 24/7 something is happening, and so when I was a PhD student, we didn't have the internet, right? So we had emails, obviously, and then the internet came and it was boring. It was like a website with a picture, right? So it took like 5 years before the internet started getting interesting. And then there was this, everybody wanted to do things on the web and so on. But I think what is happening now is that the students live at a much faster pace, and they think they need to be they interact they network much better than what we were doing, because the tools are there for networking better. That creates opportunities that also create a variety of issues. But in a sense, I think they are much more aware of what is happening in the community that we were. And so, and they are, in a sense, one of the things which is nice for them is that, in a sense, they understand what other students are experiencing. They can share a lot more what, the experience of being a PhD student or being a scientist. So they have a lot more information about how they should go about different things compared to us. We were much more isolated in a sense. So but the smaller community that we dealt with, they had also some advantages, right? So because it was easier to create communities. So it's kind of small niche communities. So this is what I see: completely different networking, completely different social interaction, a lot more information about what is happening, and that creates both opportunities and challenges.
Yeah, so the internet, I think that sums it up too. A lot of opportunities, a lot of challenges.
Yeah, opportunities. And, it's very funny because, when I was a PhD student, you had to go to a library to actually read a book or read an article. And then, I always tell the story with my daughter. And so when she was in college, I called her once and she said, "Oh, Daddy, I'm at the library." And I was like, "Oh, what books are you looking for?" I said, "Daddy, we don't go to the library to read books. It's just a quiet place." So it's very different. And no, it's not, people don't, it's very different. They don't even necessarily read books or articles. They also see a lot of things happening in different, Slack or, podcasts and things like that. Where they get their information is very different. You see what I mean?
Yes, I do. Not to date myself, but I remember doing research using the card catalog in the library and
Yeah.
The Dewey Decimal System. Is that what it was called?
Yeah.
So
it's completely different. Yes.
It is. All right, Pascal, for this next section, we're doing something kind of new and different on the podcast where we ask AI a fun or informative question. All right, so I asked AI what the best cookie or best type of cookie is, and it came with 3 runner-ups: chocolate chip cookie, oatmeal raisin, and shortbread or butter cookies. It also mentioned peanut butter cookies, snickerdoodles, macarons, and ginger molasses cookies, but those were honorable mentions. And so when I held it to the fire and asked it to pick just one that would be AI, quote unquote's favorite, it came back with a warm brown butter chocolate chip cookie with a sprinkle of flaky sea salt. So I would love to get your thoughts on that.
I think it's a fantastic choice.
Yeah, I know I'm an oatmeal raisin girl. I know, and I know
Oh, really?
controversial. I know that is something you either love or hate, but I don't know.
I like the sea salt,
Right? That was an
that's the
unexpected.
cherry on the cake, right? So
When
perfect.
pressed, AI came back with, okay, fine, I'll pick one, but I'll make it real fancy. So then I asked it asked me if I would like the recipe for the award-winning chocolate chip cookie with sea salt. So of course I said yes. So Pascal, if you'd like, I can
send it to me.
If our listeners are lucky, maybe I'll post it in the show notes when this episode goes live.
Wow, that's going to be fantastic. I want to try it.
All right, now back to more serious topics. For Informs members who are curious about diving deeper into this space, maybe folks who've worked in optimization but are perhaps newer to machine learning, what advice would you give them for just simply getting started?
On AI and machine learning and optimization, you mean, right?
Yes.
I think what was illuminating for me is when I started viewing everything in AI as optimization models or sequential decision-making models. Because I think essentially when you think about machine learning, it's an optimization. Most of the time, it's an optimization problem. And so that will resonate amazingly well with the community. And so this is not how people in AI are presenting this necessarily, right? So they have all these diagrams showing what the network is. But when you write the equations, I think you see something really beautiful, right? So you see the optimization model that you're solving. Once you see that, you get some new insight, because the optimization people are going to look at this in a different fashion, and this is I think a tremendous opportunity for the community. And I'm not the only one to say this, right? Steve Wright is saying the same thing. So these problems are different, so they open a completely new avenue for optimization models. So for optimization, the optimization community. And so what I would recommend, in a sense, okay, view everything in the lens of optimization, so the tools that we have inside the Informs community, and then start thinking about how you can address these problems in a different way from what they are being how they are being addressed right now. So this is I think this is super cool, because you start learning things and viewing things in a more systematic fashion, right? So you demystify a little bit everything. And so in a sense, at the end, this machine learning and optimizations are very, very close. They just deal with different problems, but the techniques can move from one side to the other. And this is what is happening right now, but we need more people. We need the community to grow to actually foster this. You see what I mean?
I do. And I realize I should have specified when I asked that question, diving deeper into the space of AI and machine learning and not chocolate chip cookies. So
well,
yeah. Thank you for refocusing the conversation.
No, this is okay.
Right. And for practitioners in industry or government trying to adopt AI-driven optimization, what should they be thinking about to ensure they're building something both scalable and sustainable?
Yeah, I think that's a great question. So I think we work a lot with industry. We try to take some of the research that we have applied to industry on real problems that they face. And then typically when you do that, you get some really good ideas on what to do next and so on. But the key point, is always, if you want an AI strategy, you have to have a data or digital strategy. You need the data. The data has to be there. It's to be clean. It's to be, well organized. That's number one. That's the first one thing that you need to have. The organization should be AI ready. That basically means that you have to be data ready. The data is there. The second thing that I think is important is that you want to solve the right problem. You don't want to use AI for the sake of using AI. So sometimes people come and they use AI for something that it doesn't make any sense to use it. So you have to actually think about where AI in conjunction with existing technologies can make a big difference. And I think it's like recognizing that there is a problem here, and that problem is well specified, and we believe that the combinations of these technologies can actually help. So that's the second thing. So you have to be data ready. The problem is to be chosen well. And then I think the third thing that I think is important is that there has to be this sense of integrations of different knowledge and different expertise. So when we work in power system, this is an area which is very sophisticated, and we have to know enough to actually write the right model, apply the AI technologies in the right fashion, and know what the limitations are and so on. So it's always kind of the data strategy, the good problem definition, and then making sure that you combine the technologies with deep domain expertise. That's the three things that I think is important. And then you have to basically build the platforms to address every one of those. You see what I mean? And so I think that's the way I think this can become scalable. The platform side is also very important, because this is a very different way of thinking about the problems now. It's much more data driven, and so it's very different from what people have been doing in optimization, in a sense, because now you need to make sure that you leverage that data that people have been ignoring for a long time.
I think that is terrific advice. So as much as I hate to say it, we're coming close to the end of our conversation. Yeah. But before we wrap up, I have a section of rapid fire questions where I want you to say whatever comes to mind. So get ready, get limber. You ready? Here we go.
Yeah.
A book every analytics or optimization student should read.
Wow. Okay, so that's tough. I don't have a single recommendation, so I'm going to tell you a couple of things. So I think I love, so if you start with linear programming, which everybody should start with, I think there are two books that, I love. One is by Dimitri Bertsimas, and I forgot the name of his co-author, and then the other one is by Shvatal. They're completely different. And so And so they come through the same problem in different way. And I think that's very, very important for the student to see this different perspective. And then you have to move. I mean, if you will, continuous optimization, Steve writes this, amazing book. There are many others, but this is like, yeah, this is still like, you want to know something, read those books. And then I think, I think it's a little bit more difficult on the discrete side, but, I think that Lawrence Volsi book on integer programming is still something where there are a lot of insight. People have to read it carefully to see all this insight, but it's still kind of the book that gives you some deep thinking about what where the field, what the challenges of the fields are. So that's what you start from. But then there are many others that you start reading afterwards. But that's what I would say.
There probably wasn't a fair question to ask in the rapid fire section. All right, hopefully this one is a little bit more. Do you have a favorite technique or framework to teach?
Well, you know the answer to that, right? So I'm going to say constraint programming, it's by definition, especially now where it's becoming extremely relevant to a lot of the scheduling problems that we have to solve, let's say, for instance, in the semiconductor industry and so on, and in general in engineering. But if I move to mathematical programming, I love teaching benders and generalization of benders. It's magical. I present this typically in 3 magic tricks, and they capture so many other things that, this is like, I love teaching that class. You cannot imagine.
Do you have a mentor or colleague who really inspired your thinking?
This is a completely unfair question, but because I can list every 5 years somebody. And so, my first boss was amazing. Most of my bosses, almost all my bosses were amazing, right? So my first boss is a friend, Hervé Galleri. This connection between industry and academia, that's what he was really thinking about. At Brown, we had Andy Van Damme, a legend in computer graphic, Andy in the Toy Story is labeled after him. It's how you build groups and so on. I mean, my boss in Australia, Hugh Durant-White, is amazing. A robotist. It's like, how do you build massive applications in real life? And I can list many more, but I want to give you one insight also from one particular person who really changed my life. So Michela Milano is a really good. She's a really good scientist, but she has also always a positive perspective on life. And one day she told me, Pascal, you are looking at this in the wrong fashion. You have to actually look at this as a process that you can enjoy. And this was about grant writing. And so she changed my life when she said that. And she didn't realize she was like enough comments that she made. But this is the kind of meeting all these people, meeting people like this, they change your life. And I can list many more people, obviously.
If you had to describe the future of AI in one word, what would it be?
I think I would say interesting in the sense of the Chinese, proverb, because I think it's at the same time exciting and at the same time scary. And so I think the technology is real. It's going to change the world, almost every aspect of the world. I think the key part is how do we control it in a way that is used for, the good of society in general. That makes sense?
It does, yes. I think that's probably the most accurate description of AI that I've ever heard.
Yeah.
Do you have a career lesson that you'd share with early career researchers?
So there is one thing that I think is important is to remind people why they enter the field initially. Because you do this because you want to solve a problem, or you're very interested in pushing the frontiers of science, or you want to build things. But then being part of the system, you forget about this and you look after other things. And I think the most satisfactions that you get is when you are able to step back and say, hey, I did this for this reason. I need to get back to the roots. And so that's what I want. I like to remind people of that. So and this is always the last thing that I said when for instance, I give advice to PhD students or graduate or some of the junior faculty. It's like, hey, why did you do this in the first place? Do you remember? Why did you do this? You see what I mean?
Do you have a hobby that might surprise people?
No, I don't think so. I'm pretty boring. So I try to see my kids as much as I can. And then the things that I do now, I used to play soccer competitively. Now I run. And so I love running because you get, if there are these times when you run well, you get into a zone and then it's like you are running and you don't even feel that you're running. It's like in the, I don't know if you saw the movie by the Formula One movie with Brad Pitt. And so it's driving and he's in a zone. You have that also when you are running. And so this is a feeling that is amazing. And so I love running. And the other things that I love to do is reading as many books as possible. So yeah, I love reading and running. But I don't read when I run.
I also love running. I know exactly what you're talking about. And when I go out for a run, I come back smarter and I have.
Oh yeah, you relax. Yeah, exactly.
I've solved lots of problems in my head. Yep.
Exactly.
All right. And this is my very favorite question to ask. What's one thing that's still on your personal or even professional bucket list?
So there is one thing that I would love to do. And so imagine, that you have a year left. What I would like to do is like going to 52 different places, 52 different regions, and then just explore those regions and learn about that region, talk to people there, scientists, artists, politicians, everybody who are kind of shaping that region or shaping that city, and every week is a different place around the world. That's what I would love to do. Like a year, 365 days, I would meet a person every day. I would be in a particular region every week. That's what I would love to do. Because there is so much more things to learn. There is so much more things to discover. And I think that would be amazing. If I had a year where people would invite me 1 week everywhere and learn about, kind of a new science or and learn about how artists are working and so on. I think that would be so amazing.
I think that might be the best response I've ever had to that question. I have to retire that question now. We're going to be a better response. To wrap up, today's conversation reminded us that AI is not just about automating decisions, it's about improving how we make them. Dr. Van Hentenryck's work shows that by combining optimization theory with machine learning and techniques, we can build intelligent systems that are fast, robust, and ready to handle the real world. To learn more about Pascal's work in his 2025 Informs annual meeting plenary, check out the show notes at resoundinglyhuman.com. Pascal, thank you so much for joining me, and thank you to our listeners for being part of this episode of Resoundingly Human. If you enjoyed today's show, please subscribe, leave a review, and share the podcast with a colleague.
Thank you, Ashley. It was so fun, so much fun.
This was such a pleasure. Thank you.
Yeah. Thank you.